welcome everybody. We have Ian and Marius today showing us a little bit of Java and a little bit of AWS. I'm not going to talk much more. Let's get right to it.
Good afternoon, everyone. I hope you enjoy my presentation today. Let me just share my, first let me just get the presentation up and running before I share my screen. Okay, sweet. I am going to share bits about Apparappi today and how to unlock your GPU while still using Java and all of the object-oriented stuff that comes along with it. Sorry, let's get started. Why use the GPU is an integral part of today's, excuse me.
Sorry, I think your internet is a bit slow, so turn off your video and I think then we'll be able to hear you as you're talking. Your video and audio is not quite synchronized.
Okay, so let me just, goodness gracious me. Stop video. Okay, so there's that. Okay, so as I've said now, the GPU has become an integral part of all mainstream computer systems. So every computer mostly has one, and with the increases of the GPU, the performance increases. It's actually quite amazing what you can actually achieve with the GPU. And yeah, why not try and unlock it and use it in your day-to-day tasks? I mean, there is some very powerful frameworks available that you can actually use, and you can dish out work to actually unlock the GPU. So another thing. So what is Apparappi exactly? So it was originally developed by AMD in 2010, I think. And then it dropped down in development and now it's maintained by Synclius. Apparappi is just a contraction of Apparappi, and a little tidbit of information is in the Indonesian language. The language spoken in the island of Java, it translates to what a neat. So if you have an Apparappi project, it translates to what a neat Java project, or what a neat project. And basically what Apparappi is it's an API to express solutions on your GPU. So basically, in our next slide, we'll see is you specify a kernel in Apparappi, and that kernel is basically what's the main driver and what's converted to OpenCL in this case, to actually for the GPU to actually understand, and yeah, it converts the actual Java code into OpenCL bindings natively. So you don't have to worry about knowing any OpenCL bindings. You don't have to actually worry about memory management, because Apparappi also has some my goodness words, as checks the actual bytecode of Java and then tries to make the data that comes from the program itself as smooth as possible, and actually the execution as smooth as possible. So you might just ask, why use Apparappi for this? The thing is, Apparappi is like an interface for Java between OpenCL and Java. So you don't have to learn any OpenCL bindings, especially for someone that's maybe new to programming or doesn't have the time to actually learn OpenCL to actually get the power of the GPU to actually run stuff on the GPU. it's not always feasible. So Apparappi is also intelligent in this way because it defaults to the Java thread pool if you don't have this OpenCL enabled device on your computer. So you will still get some kind of what do you call it, a performance increase from the GPU or from Apparappi itself, because it defaults to the Java thread pool. It uses all the available threads that it could actually theoretically have, and then you will still find a big performance increase on it. So yeah, like I said, it analyzes the Java bytecode to maximize the efficiency of the algorithms that you dish to it. And yeah, and because OpenCL is made for not only GPUs, but OpenCL can run on CPUs and other devices as well. You're not locked to only the GPU. So the OpenCL can be dished to any oh, goodness sake, any processor or any processor that supports it. And like I said, it's much more simple to actually just write Java natively and understand what the method calls does in that, and then let Apparappi takes care of the rest, as what it is to learn what is all of these functions here. I mean, I'm not even entirely sure what all of these functions does, and as you'll see in most of the other APIs or other packages that you have available for running Java on a CPU or a GPU, sorry, it's more of like a bindings for I think it's in the next slide, yeah. It's almost like as it's bindings for the OpenCL framework or the CUDA framework. It's not entirely something that you'll actually, so you'll actually still need to learn OpenCL or CUDA to actually get the power of it, because it's just like it's basically like a adapter just for OpenCL. It doesn't actually convert your actual code to OpenCL as what Apparappi does. So the caveats of this is that the GPU is designed for a specific class of applications, and you can't always get the performance increase that you want from it. I mean, some of the things that the GPU excels at is applications where the computational requirements are quite large. I mean, for a CPU to render a 8K image or something like that, it will take immense amount of time just to get that, where the GPU is just better at that point. Another application is where parallelism is substantial. So you'll need actual multiple processors running or something like that to actually get the most out of it. And then another application is where throughput is more important than latency. If you want something to be done fast and not worry about actual slowness of the data transfer or something like that, it's guaranteed that it will be a great application to run for your GPU to take over. Caveats of Apparappi itself, it only supports primitive arrays. So you can't make an array of, say, objects or something like that. I know root beer, I think it's root beer, is also a package that you can import for Java that also converts to, well, not also convert, it converts it to CUDA. So you're actually limited only to NVIDIA graphics cards. Where you can actually go and specify that it's object arrays or something like that, and then do something in that those arrays itself. Double precision is not supported by all cards, so gamer hardware is made for floating point operations. So anything byte 32 bits, I think, should be work fine on any gamer hardware. Other than that, more higher end graphics cards like Tesla, for example, of NVIDIA is more made for double precision, where it's actually meant to help on data centers and stuff like that. The code needs to be refactored. I mean, not everything will work the first time on the GPU. And yeah, like I said, GPU programming is data-centric, compute-bound. So the more data and where the actual computations are quite intense, if you can say that. And then also, as you'll see in my demo now, is that the first execution of a kernel is very, very slow, because what Apparappi does, it goes and converts that bytecode into actual OpenCL. So it will first need to compile, then Apparappi is like a subroutine that comes in. It analyzes the bytecode and then converts it into OpenCL. So let's get started. I'm just going to stop share because I only have the sharing for the presentation. So let's jump into that. So yeah, simple enough. Let me start with the CPU test. So what I did is I went and gotten a 12K image there. And I'm just going to apply a simple convolution. So in this case, let me just copy this one over so that you can actually see something once we are done. No, you know what? I'm just going to share my entire window so you can actually see the pictures and stuff like that. Okay, so just going to copy this convolution matrix over. I made some changes. So let me just get that picture open for you guys. Okay, so this is the picture that I'm going to do a convolution on. So the actual convolution is like an edge detection. I actually wanted to do that so that you can actually see an actual difference in the picture. So simple enough, it just applies the convolution 10 times. Just to get a baseline for it. And this is the CPU version. So let's run this quickly. No, I'm running the GPU test now. Fun. Let me just stop that. CPU test. Okay, sweet. And as you'll see for that 12K image, it takes about 4 seconds. So it takes quite a while to actually for the CPU to get all that data in and process it, etc., etc. So let's go to the GPU test, and then I can show you how the kernel works. So the kernel itself, all that you need to do is just override a run method. So it's much like, for instance, when you have threads or something like that, you just override the run method, and then at the end of the day, you will it will run by itself and stuff like that. In this case, it just calls a method process pixel that gets the pixel values that it needs to convolute to. And this is for the CPU what gets out. So you can see here, it's only the edges that you get back. Actually a quite nice edge detection there. So yeah, that's for CPU, and you'll see, you saw it's an average of 3.3 seconds. So for the GPU test, you will see it's much faster. The first one takes 3 seconds because, like I said, it needs to convert the actual bytecode into OpenCL and then dish it out, and then it does the work, etc., etc. But the rest of it's 100 milliseconds. I just said there seconds because that was a typo. I wanted to change that, but I forgot. But in any case, the average for all 10 of them are like 400 milliseconds. which is quite substantial. I mean, it's an 8K image. It's very, very much pixels, if you can say that. And then as you'll see here, the same goes here for the output. So yeah, I think that is that.